For question 5, block test, time trial, stats section, question 5. Let's take a look at the question. The question says that in a computer game, we have a bug moving from left to right through a network of connected paths. The bug starts at S and at each junction randomly takes the left fork with probability P or the right fork with probability Q. Alright, and at this juncture, you notice that Q plus P equals 1. And we also notice that there are two possibilities. Either the bug takes the left fork or the right fork. The fork taken at each junction are independent. And the bug finishes its journey at one of the 9 endpoints labeled A to I. Alright, so the first part of the question requires us to show that the probability that the bug finishes its journey at D, where is D? D is over here, where it started with S, is given by this probability. Alright, so if we study closely the path that the bug will have to take from S to D, we can see how many turns he is able to take. Alright, so let's say for example, if I start from here, from S, alright, so I have I turn left, okay, then I want to turn right, alright, then I turn left again, I turn right, left, right, left, and left. So you can see from here, I have 1, 2, 3, 4, 5, 6, 7, 8. So altogether, the bug will have to take 8 steps. Okay, 8 steps from S to D. Even if you try another route, it will be the same. All right, so we can try out another route to verify this. So let's say I take this route. Okay, so I have right. Okay, I want to continue right. Okay, then I decided that if I want to take continue to D, I need to go left. So left, 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 left. Okay, so you can see again 1, 2, 3, 4, 5, 6, 7, 8. I need 8 steps. Okay, but you can see no matter what is the combination of left and right, you would need 3 left turn and 5 left turn and 3 right turns. Okay, 5 left turns and 3 right turns. And from the first paragraph, you can also see that there are 2 outcomes. Okay, there are 2 outcomes. Either you have left turn or right turn, and you have a fixed probability, a constant probability of taking the left fork, which is P. Okay, and the question also says that the events that you take, whichever fork, left turn or right fork, they are independent. Okay, and number 4, we know that there is a fixed number of steps, which are 8 steps. So if you combine these observation 1, 2, 3, 4, we can more or less establish the model for this question, which is a binomial distribution. So which means that for part 1, we need to use binomial distribution to find the probability. So what is the random variable that we have to define here? All right, so let's take a look at the definition. So first of all, we let x be the random variable representing the number of steps to the left, okay, because we're talking about to the left, right? So if you want to consider to the right, then you are not taking P. You have to consider Q. All right. So you can do either way, but in this case, I would think that it is more intuitive to consider the left fork, so we can use the P. So the number of steps to the left out of 8 steps. So remember, a quick revision, if you want to define a random variable for binomial distribution, you must always align with the generic definition, the number of success out of n trials. Okay, so this is how we define a binomial distribution. So for this case, what is a success? The success will be the step to the left. That means the bug taking a left fork. And out of n trials is in total with 8 steps. All right. So we therefore have a binomial distribution. X follows a binomial distribution 8p. So 8 is the n and p is the probability of success. So just now when you see I demonstrated on the diagram, for a bug to finish at D, the destination is D, altogether we need 5 left steps. All right, let's go back to the question. We need 5 left steps, right? Correct. So therefore, this is equivalent to saying that Px equals to 5. And according to the binomial distribution, a quick revision again, Px equals R is 8 choose R, P power R, Q power 8 minus R. So for this case, if my R is 5, I would have 8 choose 5, P power 5, Q power 3. So 8 choose 5, you can evaluate using your scientific calculator, or your GC is equals to 56. So this is how we managed to show the answer. There is a note for students which says that the bug has to make a decision to make the left or right turn at 8 different junctions. And at 5 of the 8 junctions, the bug will have to make a left turn. So that's why I mentioned 5 left turn. So that is how you arrive at 8 choose 5. Okay, so this is your first part. Let's move on to the second part. The second part says that given that the probability that the bug finishes its journey D is greater than the probability that the bug finishes its journey at any one of the other endpoints. So what does it mean? It means that the probability that the bug finishes at D is the highest probability, because when you compare to any other endpoints, this probability is the highest. So which means that what we gather from here, this is the modal probability. So x equals to 5. 5 is the mode. Okay, and using this information, you have to find exactly, that means it must be in decimal places, it must be in terms of fraction, the possible range of values of P. So when they mention possible range, it means that you should anticipate to form an inequality for your answer. All right. So there are a few things that I mentioned here. One is x equal to 5 is the mode. Okay, and you have to formulate an inequality for the answer for P, and the final answer must be in terms of fraction. So you can see this phrasing is actually quite concise, but it actually consists of a few information requirements that you have to read very carefully. All right, so let's look at the solution. As I mentioned that because x05 is the modal number, notice that the question is not explicit. They didn't tell you that, oh, x05 is the modal number. In fact, they told you that this probability is greater than any one of the other junction. So sometimes the phrasing can be very subtle, but you have to filter the information for you, read between the lines, and make the right decision on what you should do. All right. Okay. So knowing that Ps equals to 5 is the highest, we get that x equal to 5 is the modal number. So now we will then compare, because the values closest to 5 is either 4 or 6, right? 4 or 6, because on the left you have 4, on the right you have 6. So we will do a comparison because px equal to 5 is the highest, right? That means px equals to 5 definitely is more than px equals to 4. Likewise, we also have px equals to 5 more than px equals to 6. And at this juncture, pause for a while. So some of you might wonder, why is it I have to compare with the immediate neighbors, 4 and 6? Why is it I cannot compare with x equals 0, x equals to 8? Why? Okay, so this one is food for thought. Okay, and if you want to find, because in this case, your P is actually unknown. Remember, the question actually asks you to find the possible range of values of P. So when you want to find a range to capture the unknown P, you have to ask yourself, if let's say I ask you to find this range, do you prefer to have a wider range or a narrower range? Do you prefer a wider range for P or a narrower range? Okay, you're going to think about it. If you ask me, my answer would be a narrower range for P is much better because it's easier for us to nail down what is the exact value of P. So imagine, just consider one analogy. Let's say you want to find a friend. Okay, you are supposed to meet a friend at a shopping mall. So if your friend say, "Oh, I'll be there. The shopping mall there are 10 stories, so I can be found at any one of the 10 story. You can just go and look for me." Okay. So of course you'll feel very frustrated as compared to another friend who says that, "Look, I'll be standing in front of let's say McDonald. Then you will be able to find me there, right?" So remember, this is very simple analogy. All right. So remember, if whenever you want to find an unknown value of P, you should always find a range that is tight, small, so that you can easily find the unknown P. All right. So I hope you remember this. All right. So go back to our two inequalities. We have already shown that x equals to 5 probability is 56p5q3 from the first part. So likewise, you can use the binomial PDF expression, the formula, to find out Ps equals to 4 as well as Ps equals to 6. Then you simplify this and you are able to get P more than 5 quarter Q and P less than 2Q. Okay, just simplify. And from here, we know that Q equals 1 minus P. All right, then you solve for P, you get P more than 5/9 and P less than 2/3. Okay? And remember, these two inequality must be fulfilled at the same time because Ps equals to 5 is more than Ps equals to 4. And at the same time, it is also more than Ps equals to 6. So you are going to take the intersection. It is not either or situation, but it is a situation whereby both inequalities must be satisfied. So that's why we are taking the intersection. Right? So after taking the intersection, we'll have P more than 5/9 and P less than 2/3. So that's the answer. Okay, so let's move on to the last part of the question. In another version of the game, the probability that at each junction the bug takes the left fork is 0.9p and the right fork is 0.9q, but there is one more thing introduced here, which is the probability that the bug is swallowed by a black hole. The additional feature is 0.1. Then you have to find the probability that in this new version of the game, the bug reaches one of the endpoints A to I safely without being swallowed by a black hole. Okay, so it can pass by, navigate itself very happily, but it will not be swallowed by the black hole. So notice that the mark given is only 1 mark, which means that you shouldn't be doing a lot of working for this solution. Okay, so don't overthink. All right, so let's quickly try to solve this. In this case, I'll define y as a random variable that represents the number of steps out of 8, still the same, that ends up at the black hole. Okay, so remember it is a different random variable. Do not use x again because you are describing a different situation. And if you're finding the probability that the bug can navigate from S to any of the endpoints A to I without falling into a black hole, that means y equals 0. Okay, because it it doesn't step into any black hole. Okay, so y equals 0, you get the answer, three significant figures. If let's say you don't want to use binomial distribution, also fine. All right, then you have to interpret that every 8 steps, every 8 junction that happen, the probability is 1 minus 0.1. Okay, so 1 minus 0.1 power 8, because 0.1 is the probability of the bug fallen into the black hole. So if I have 8 junction, okay, no matter what you take, okay, so every steps that this bug take will not be ending up at the black hole. So I have 0.9, 0.9, 0.9, so on and so forth until you navigate to from S to, let's say, F, something like this. So there are 8 steps. Okay, there are 8 steps, but every step it managed to navigate safely. So it is 0.9 power 8, which is also 0.430. All right, so you can use either method. You can use the binomial distribution, or you can use the non-binomial distribution. All right, so this is the question 5.